Right, we're asked to find the coordinates of the stationary points. So what are the concepts involving stationary point? So concepts. So we have learned that for any stationary point, or rather to find any stationary point, okay, we let dy over dx equals to 0. Okay, right. So from y equals to sine x plus 2 cos x, let's find our dy over dx. So you differentiate sine x, you get cos x. And you differentiate cos x, you get negative sine x. So in the end, your dy dx is cos x minus 2 sine x. Right, so we let dy over dx equals to 0. So you would get cosine x equals to 2. Sorry, you will get cosine x minus 2 sine x equals to 0. Alright, so in the chapter of solving trigo, do recall that you can only solve trigo equations when there's only one trigo function. So right now we actually have two trigo functions. We have sine x and cosine x. So we need to convert it into just one trigo function. Right, so what connects sine and cosine and tangent x? What's the connection among these three things? Right, so if you do remember, tangent x is actually equals to sine x over cos x. Right, so what we're going to do is we're going to rewrite this equation okay. So I'm going to divide by negative 2 cos x on both sides. Alright, so I would end up negative divided by negative will gives you 1. Sine x divided by cos x will be tangent x. And then negative cos x divided by negative 2 cos x will gives you half. Okay, so for solving trigo equations, right, we need to find this thing called the reference angle. In some textbook, they call it the basic angle, and the symbol used is alpha. And this reference or basic angle alpha is always in the cube angle. A cube angle is an angle more than 90, more than 0, less than 90. Okay, right, so we need to find alpha, which is our acute angle. So tangent inverse half. Oh wait, before we actually find the values of x, okay, the next concept that we need to recall is your ASTC. Right, so in other words, for tangent to be positive, the angle x will come from the first quadrant and the third quadrant. Right, so let's find angle alpha first. So alpha is tangent inverse half, and you have to change your calculator mode to the radian mode, because if you're doing differentiation integration, the angle used in your trigo functions will have to be in radian, right? So we change it to radian mode, shift mode, then change to radian, which is 4, tangent inverse 0.5. So you would get a 0.4636. Okay, 0.4636. Okay, and right, so just now we mentioned that for tangent to be positive, the values of x must come from the first quadrant. So therefore your first answer would be 0.464, trace significant figure. And the second answer will have to come from the third quadrant, which is 180 plus alpha. 180 is equals to pi, so it's pi plus alpha, which is plus 0.4636, and that will give us 3.61. Okay, so your 2x coordinates would be of the stationary point would be 0.464 and 3.61. This chapter on differentiation of the trigo functions is very closely related with the trigonometry we have learned earlier on, right? So you have forgotten some of those like trigo identities, like sine square x plus cos square x equals to 1, 1 plus tangent square x equals to secant square x, 1 plus cotangent square x equals to cosecant square x. Then it is a good time for you to revise some of these concepts. You can refer to your book A, right? The trigonometry chapter is from book A. Right, so let's look at part 1. Okay, so you're asked to show that the gradient function, right? So what does gradient function refers to? Yes, the gradient functions refer to your dy over dx. Alright, so basically we need to differentiate y respect to x. And if you look at the functions you're given, alright, what you're given is 4 cos x over sine x. So to find your dy over dx, in this case here, we would have to apply the quotient rule. So we're going to let u equals to cos x, 4 cos x, let u equals to 4 cos x, and v equals to sine x. Right, so du over dx, if you differentiate cos x, you would get negative sine x. So that will gives you negative 4 sine x. And if you differentiate sine x, you would get cos x. So the next step is to write down the formula to find to apply quotient rule to find your dy dx. So that is v du over dx minus u dv over dx over v squared. And that gives you sine x. Du over dx is negative 4 sine x minus u, which is 4 cos x, multiplied by cos x over v squared. So v squared is actually sine x times sine x. And if you remember, we said it before, sine x times another sine x actually is equals to sine square x. Right, so that simplifies further. Alright, so if you look at the numerator, the common factor is negative 4, so we can factorize a negative 4. Okay, and if you were to recall, right, just now I mentioned the trigo identities. So one of them is actually sine square x plus cos square x gives you 1. Right, so that will gives you negative 4 times 1 over sine square x. Gives you negative 4 over sine square x. Okay, so this is exactly what you're asked to find here. Okay, where your k is actually negative 4. Right, so from part 1, we have managed to find your gradient function, which is your dy dx, and we found it to be negative 4 over sine square x. So let's look at what we need to do for part 2. So part 2 is pretty wordy. Okay, it's very wordy. You will have to find tangent, and this tangent is perpendicular to a line. So if you find this very wordy, I would advise you just to do a simple sketch. Right? So you have a curve, we don't really have to worry how the curve looks like. You have a point here, and this is the point that we need to find, the x coordinate. We don't know what is the point. So, and then at this point here, we can draw our tangent line. So this is our tangent line. And this tangent line, it's perpendicular to a line where this line, you're given the equation to be x minus 8y equals to 2. So from here, I can actually find my gradient. Alright, so you would have negative divided by negative positive, x over 8 is the same as 1 over 8x. Okay, x over 8 is the same as 1 8x. 2 divided by negative 8 will be negative 1/4. Alright, so from here, the gradient of this perpendicular line, you can actually use the short form, write your, okay, this is the short form for perpendicular line, and the gradient, it's this value here, which is 1 over 8. Okay, right, so what is the next thing, what's the next piece of concept involved here? Two perpendicular lines, how are they related? Right, so if you have gradient of your perpendicular line to be 1 over 8, then the gradient of your tangent line would be negative 1 divided by the gradient of your perpendicular line, which is 1 over 8. So you divide, change to divide 2 times, and then you have to flip 8 over 1, 1 over 8 to get 8 over 1. 8 over 1 is 8. So your gradient of your tangent line is negative 1 over 8. Alright, so this gradient, negative 8, right, is equal to what we have found in part 1. This value here is equals to what we have found in part 1. Okay, so we're going to equate, or rather, we're going to let negative 4 over sine square x equals to negative 8. Okay, so we do a cross multiply, you get 8 sine square x equals to negative 4. Sine square x will be negative 4 divided by negative 8, that gives you half. Okay, so sine x, sine square x means sine x times sine x, so it's the same as, if you write it this way, sine x times another sine x, so it's the same as bracket sine x close bracket square. Right, so how do we solve something like x squared equals to 4? We would have two values, right? Positive 2 or negative 2. So likewise, okay, the sine x can be positive or negative square root 1 over 2. And that, again, if you apply your, so in this question here, actually, it involves a few chapters. It involves coordinate geometry, because you need to know that the gradient of perpendicular line times your gradient of the tangent line gives you negative 1. The gradient of the normal line times the gradient of the tangent line, because normal and tangent line are perpendicular to each other, gives you negative 1. First concept. Second concept, it's you need to remember your third. Okay, what is that? That is, if you have square root a over b, that gives you square root a over square root b. So here will gives you plus minus square root 1 over square root 2, and square root 1 is 1, so plus minus 1 over square root 2, and if you rationalize it, you will get plus minus square root 2 over 2. Right, so if you look at the answer that you're given, the questions you're asked to find, it says the exact form. Exact form in Trigo, if you're asked to leave your answer in exact form, It could be in terms of pi, or it could be the angle given, special angles. So what are the special angles? So this is the third concept involved here. So special angles are angles like 30 degrees, 60 degrees, and 45 degrees. Okay, right. So we have to find your reference angle first. Reference angle is a positive, it's a acute angle, between 0 to 90. So we only take the positive value of your sine x. Remember, we take only the positive value of your sine x, which is positive square root 2 over 2. So your alpha is sine inverse the positive value only, which is square root 2 over 2. And that gives you 45 degrees. Okay, so we mentioned earlier on that when you do differentiation involving trigo, the angle given has to be in radian mode. So we convert 45 degrees into radian mode. That will be 45 over 180 pi, and that actually gives you 1/4 pi. All right. So now you know that the answer value you would have, if you recall your ASTC, right? Sine positive, the value when sine x is positive in the first and second quadrant, but because you have plus minus here, meaning that the values of x will come from all the 4 quadrants. All the 4 quadrants. However, let's read the questions again. The question says that, okay, the values of x, they only want to restrict it to the first and the second quadrant. So even though you can have the values of x from first, second, third, and fourth, all right, we only restrict it to first and second quadrant. First and second quadrant. All right. So therefore, your values will be x equals to 1/4 pi, which is your first quadrant. Second quadrant will be pi minus alpha, which is pi minus your 1/4 pi, gives you 3/4 pi. Okay, so your x coordinates of the points at which the tangents to the curve are perpendicular to the line will be 1/4 pi and 3/4 pi. Right, so question 10, you're asked to find the rate of change of y. Okay, rate of change of y. So what is rate of change of y? What do you need to find when it says rate of change of y? It means you need to find your dy over dt. Okay, so we need to find dy over dt. So we need to find. So for connected rate of for rate of change, remember we have to, step 1 is to write down what you're given. Step 2 is to write down what you need to find. Step 3 is to form your connected rate of change. So if you look at what I've underlined in red, this is what you're given. You're given that x is decreasing at the rate of 0.5 radians per second. So what does it represent? It means dx over dt, and it's decreasing, so there should be a negative sign there. 0.5 radian per second. That means in 1 second, okay, in 1 second, the values of x is 0.5, smaller by 0.5 radian. In 2 seconds, it's smaller by 0.5 times 2. That gives you 1 radian. In 3 seconds, it's 0.5 times 3, so on and so forth. So your values of x get smaller and smaller and smaller and smaller. All right, so we have step 1, step 2. Now we do step 3, which is to form the connected rate of change. So we start from what we need to find, which is a dy over dt equals to what you are given. Okay, it's always what you need to find equals to what you're given times something new. And this something new is your dy over dx. Right, then you ask yourself, where does your dy over dx come from? What does dy over dx means? So dy over dx means is the rate of change of y respect to x. And where do you get it from? You get it from the equation y equals to cos squared x plus 1 quarter. Right, so from this equation that you're given, we need to find your dy over dx. So, okay, so we need to differentiate cos squared x. So how do we differentiate cos squared x? First step, bring the power down. 2 cos, power minus 1, so 2 minus 1 is 1. Second step, just differentiate your cos x without the power. And also you need to differentiate 1 quarter, but 1 quarter is a constant. So you differentiate a constant, you get a 0. You differentiate cos x, you get negative sine x. So you end up getting negative 2 sine x cos x. Alright, so it says that find the rate of change of y when y equals to 1. But if you look at what you get for your dy dx is in terms of x. So we need to know what to substitute for x. So how do you know what you need to substitute for x? I need to substitute y equals to 1 into your curve, into the equation. Right, so I'm going to do it here. Use a different color. So I'm going to sub y equals to 1 into y equals to cos squared x plus 1 quarter. Then you will have cos squared x plus 1 quarter equals to 1. Cos squared x will be 1 minus 1 quarter gives you 3 quarter. Cos x will be plus minus square root 3 quarter. So again, apply the concepts of surds. Plus minus square root 3 over 2. So the plus minus square root 3 over 2 tells you that the angle x will come from all the 4 quadrants, first, second, third, fourth. However, if you look at the questions again, they only want the answer from the first quadrant. Between 0 and pi over 2 means the first quadrant. So you don't have to worry about the second, third, and fourth. Alright, so we need to find alpha. Alpha is a reference angle. Alpha is always positive. So you take the positive value of your cos x, which is square root 3 over 2. So you would get 30 degrees. Convert it to radian is 30 over 180 pi, which is 1 over 6 pi, or pi over 6. So alpha is an acute angle, and alpha is an angle between 0 and 90, which is the first quadrant. And the first quadrant is the answer you're interested in. So therefore, your x that you need to use is 1 over 6 pi. Okay, so with this x equals to 1 over 6 pi, what do? I substitute into your dy over dx. And then also into, finally, I can find your dy over dt. So let's look at your dy over dt equals to negative 0.5 times your dy over dx, which is negative 2 sine x cos x. So times bracket -2 times sine pi over 6 cos pi over 6. And let's see what answer you get. Now, if you're using pi over 6, make sure you remember to change your calculator mode to radian. Right, so you have negative 0.5 times bracket -2 times sine pi over 6 close bracket cosine pi over 6 close bracket. You will get 0.433, three significant figure. And the units will be radians per second. So the rate of change of y will be 0.433 radians per second. All right, so if you look at this question, the figure S is made up of a triangle ABC, which is an equilateral triangle, because you have AB equals to AC, so it's an equilateral triangle, and also make up of the rectangle. Right, so to find area of a triangle ABC, we can use half AB sine C. So you're given, this could be your values of A, BC, it's the values for B, and then you have the angle, including angle, which is theta. Right, so I need to find the length BC. So how do I find the length BC? I'm going to use Stochastic to find that. So I'm going to draw a line from A, a perpendicular line from A to BC, and I'm going to call this point here X. Right, so I'm going to use Stochastic to find BX. So if I'm using the angle theta, then this will be your opposite. This will be your hypo. This will be your ADJ adjacent. So if you write down your Stochastic, you need to find A and you're given H. So you can use cosine to find BX. So therefore cosine theta will be adjacent, which is BX, over your hypo, which is 8. Right, so we do a cross multiply, BX times 1 is BX, 8 cos theta. So therefore the length BC is 2 times BX, so that will give you 16 cosine theta. Okay, so if you have BC equals to 16 cosine theta, we can find the area of triangle ABC using the formula half AB sine C, which you learned it in your elementary trigo. So the A, you can let your A be 8 cm, B, it's the length BC, which you found to be 16 cosine theta, and the angle theta, so be sine theta. So if use a calculator, work that out, half times 8 times 16, that will give you 64. Sine theta, cosine theta. Alright, okay, sine theta, cosine theta. And that is not the end yet. You have to find the area of the rectangle. So area of rectangle will be length times breadth. So it will be 4 cm times ED, which is the same dimension as BC, which is 16 cos theta. So 4 times 16 cos theta, that will give you 64 cosine theta. So you add both of them together. So part 1, area S will be equals to 64 sine theta cos theta plus 64 cos theta. Right, so that will be part 1. So for part 2, okay, you're asked to find the values of the theta which give S a maximum value. So for maximum minimum value, it's the concept is the same as finding maximum point or minimum point. So maximum point, minimum point are stationary point. So the concept involving stationary point is every time you need to find stationary point, you let dy dx equals to 0. So from what you're given, found in part 1, S is equals to 64 sine theta cosine theta plus 64 cosine theta. right? So I need to find the s over the theta. Okay, you're not given y, so you're given s instead. So you're supposed to find the s over the theta. Okay, so what I need to do is I'm going to rewrite 64 sine theta cos theta as, so there's a little bit of trigo here that you need to remember. 64 is 32 times 2. 32 times 2 gives you 64. Why do I want to write it as this? You will see what happened. Okay, 2 sine theta cos theta. Do you recall? We learned 2 sine theta cos theta in a double angle in trigo. And 2 sine theta cos theta is sine 2 theta. Okay, if you've forgotten that, please revise. So from there, you can get your ds over d theta. Okay, so we need to differentiate sine 2 theta. Differentiate sine 2 theta, you will get cos 2 theta. Differentiate 2 theta, you get 2. Right, differentiate cos theta is negative sine theta. So you simplify to get 64 cosine 2 theta minus 64 sine theta. Okay? Right, so for stationary, for maximum value, which is a stationary value, we let the s over the theta equals to 0. So we're going to solve for that. So we do it at the next slide. And you manage to find the s over the theta equals to 64 cos 2 theta minus 64 sine theta. So for stationary value or stationary point, we let the s over the theta equals to 0. So 64 cosine 2 theta minus 64 sine theta equals to 0. If you look at it carefully, the common there's a common number there, which is 64. So I'm going to divide by 64 throughout. So you end up getting cosine 2 theta minus sine theta. 0 divided by 64 is 0. All right, so we can't solve a trigo equation where there are two different trigo functions. We have to convert it into one single trigo function. So this again is a concept of your trigo, the formula, double angle formula. So recall that cosine 2 theta, there are three different formulas for cosine 2 theta. One of them is 1 minus 2 sine squared theta. The other one is 2 cos squared theta minus 1. The third one is cos squared theta minus sine squared theta. So obviously we have to use the first one. Okay, why you have to use the first one? Because the second trigo function in the equation is sine theta. Right, so I'm going to rewrite cos 2 theta as 1 minus 2 sine squared theta minus sine theta. Okay, I'm going to multiply every term by negative 1. The reason is I want to make negative 2 sine squared theta to be positive. Okay, and if you use your calculator to factorize it, to help you to do the factorization, okay, you will have 2 sine theta minus 1 and sine theta plus 1. So from there, you can have sine theta equals to half or sine theta equals to negative 1. Okay, right. So if you look at, if you go back to the questions, we will have to reject sine theta equals to negative 1. Okay, and then accept sine theta equals to half. So as usual, you have to find your reference angle, right, which is the acute angle that's between 0 degrees to 90 or between 0 and pi over 2. So positive value, sine inverse half. Sine inverse half is 30 degrees. That gives you 30 over 180 times pi, 1 over 6 pi. Okay? Right, so your theta, if you look at the diagram, the theta obviously is an acute angle. Right, it has to come from the first quadrant. So your first quadrant is the same as your reference angle because the first quadrant is between 0 and 90. Your reference angle is also between 0 and 90. So therefore your theta it's equals to 1 over 6 pi. However, we need to verify that this angle will give you a maximum value. So how do I verify that it will give you a maximum value? We're going to use second derivative, okay, to verify that. So what is second derivative? Second derivative means I differentiate the s over the theta again. So I differentiate the s over the theta again. You will get the 2s over the theta squared. I'm going to differentiate this again. I will get 64. Differentiate cos 2 theta will be negative sine 2 theta times 2. Differentiate sine theta, you get cos theta. So you simplify it, you will get negative 128 sine 2 theta minus 64 cos theta. So I'm going to substitute theta to be 1 over 6 pi. Make sure you remember to change your calculator mode to the radian mode. So at theta equals to 1 over 6 pi, substitute into your d2s d theta squared, negative 128 times sine minus 64 cosine pi over 6. You will get negative 166.3, and negative 166.3 is less than 0. So hence theta equals to 1 over 6 pi will give area as a maximum value.